What if the most important number in factory automation isn't $1 million or even 100,000, but 30? A robot arm for $30 sounds almost absurd, and that's exactly why this story matters. Because if a useful piece of factory automation really can move toward that kind of price point, the biggest change may not be the robot itself. It may be what happens when automation stops being something only large factories can afford. For decades, robotics came with a hidden barrier. The technology could be incredibly useful, but useful wasn't enough. A factory had to justify the robot, the installation, the programming, the maintenance, the supporting equipment, and all the other costs surrounding it. That meant automation made the most sense when a company was already big enough to spend serious money. A giant automobile plant could do it. A massive electronics factory could do it. But what about a small manufacturer making thousands of different parts? What about a workshop with 20 workers or 50? For those businesses, the question wasn't always, can a robot do this job? It was much simpler. Can I afford to automate it? And that question is beginning to change, because China's robotics story isn't really about one cheap robot arm. It's about something much larger, a manufacturing ecosystem that has spent years making industrial technology easier to produce, easier to source, and potentially cheaper to deploy. And there's one detail here that makes the whole story more interesting. China isn't entering a world where nobody uses robots. Quite the opposite. China has already become the world's largest market for industrial robot installations, with hundreds of thousands of robots installed in factories in a single year. That matters because when you have an enormous domestic market, something unusual can happen. Factories don't just buy technology, they help create the market that makes the next generation of technology cheaper. Think about what happens when a manufacturer needs thousands of motors, then another manufacturer needs thousands more, then a company making controllers needs components, then another company starts making sensors. Then suppliers begin competing for those orders. The result isn't simply more products, it's pressure to make them faster, pressure to make them smaller, pressure to make them more reliable, and eventually, pressure to make them cheaper. That's where the $30 idea becomes much more interesting, because the price of a robot isn't determined by the robot's outer shell. Inside that machine are motors, gears, electronics, controllers, sensors, software, wiring, mechanical structures, and dozens of other pieces. If even a few of those components become dramatically cheaper, the economics of the entire machine can begin to move. But here's the part people often miss. China's advantage isn't simply that something costs less to manufacture. The deeper advantage can come from having many parts of the supply chain sitting close together. Imagine a company designing a new robotic arm if its motor supplier is nearby, its electronics supplier is nearby, its machining supplier is nearby, and its assembly operation is nearby. The company can test changes quickly. A problem appears on Monday. A new component can be discussed on Tuesday. A revised version can be tested shortly afterward. That speed matters, because manufacturing isn't just about producing something cheaply once. It's about learning how to produce it better, faster, and cheaper again and again. And this creates a strange feedback loop. More factories buy robots. More robots create more demand for components. More demand attracts more suppliers. More suppliers increase competition. Competition pushes prices down. Lower prices make robotics accessible to more factories, and those factories create even more demand. The machine gets cheaper, because more people can afford the machine. That's the first major shift, but it isn't the biggest one. The bigger shift happens when a factory that never considered automation suddenly starts considering it. Imagine a small manufacturer, not a giant corporation, just a company trying to stay competitive. Its workers are experienced. Its orders are growing, its machines are aging, and every new contract creates the same problem. How do you produce more without sending costs through the roof? For years, the owner might have looked at industrial automation and thought, maybe later. Not because the technology was useless, because the economics weren't attractive enough. Now imagine the calculation changing. The question becomes, what if I don't automate? That's a completely different question. And once that happens, the market can move surprisingly fast, because the first company to adopt cheap automation may gain a small advantage. The second company sees it, then the third, then customers begin expecting lower prices. And suddenly, automation isn't a luxury anymore. It's becoming part of the competitive baseline. That is where this story takes an unexpected turn. The real threat isn't necessarily that a $30 robot arm replaces an expensive industrial robot overnight. That would be too simple. The real possibility is that cheap robotic hardware expands the number of jobs in factories where automation makes economic sense, and that changes the size of the market itself. Think about smartphones. The important transformation wasn't just that phones became cheaper. It was that billions of people who previously didn't have advanced computing in their pockets suddenly did. Cheap technology doesn't merely capture existing demand. Sometimes it creates new demand. Robotics could follow a similar pattern. A large factory may already have hundreds of robots. A small factory may have none. So when robotics becomes cheaper, the first opportunity isn't necessarily stealing a customer from an existing robot supplier. It can be creating a customer who never existed before. That is a much bigger market opportunity. And this is where established automation companies could face a difficult question. What happens when customers stop asking for the most sophisticated system they can buy and start asking for the cheapest system that works? That's uncomfortable, because high-end industrial automation isn't simply a metal arm. Companies build entire systems around reliability, safety, integration, software, service, and precision. Those things still matter. A factory cannot afford a machine that saves money but stops production every afternoon. So cheap hardware alone doesn't guarantee disruption, but it does something dangerous to the old business model. It puts pressure on the assumption that advanced automation must always be expensive, and once that assumption starts breaking, the economics begin spreading outward. A cheaper robot can make a smaller factory more competitive. A more competitive factory can pressure its suppliers. Those suppliers may automate too, then their competitors respond. And suddenly, a single piece of inexpensive hardware has created a chain reaction. This is why the $30 figure is psychologically powerful, not because $30 magically transforms a factory, but because it represents the possibility of a much lower entry point, and entry points matter. When a technology is too expensive, millions of potential users simply disappear from the market. When the price falls far enough, those users come back into the calculation. That is how industries can change without one giant breakthrough. Sometimes the revolution is not a robot that can do something nobody has ever seen before. Sometimes it's a robot that can do something ordinary for a price that makes ordinary factories willing to try it, and China has an unusual position in this race. It has an enormous manufacturing base that can consume automation at scale. The International Federation of Robotics reported that China accounted for 54% of global industrial robot installations in 2024, while Chinese robot makers captured a majority share of their home market for the first time. That doesn't mean Chinese companies automatically win the global robotics industry. They don't. Japan, Germany, the United States, South Korea, Europe, and many other economies have deep expertise in industrial automation. And advanced robotics still has difficult problems to solve. Precision matters, safety matters, software matters, reliability matters, integration matters, but China's scale creates something powerful, a huge testing ground. When millions of factories are competing to make products faster and cheaper, even small improvements in automation can become economically important, and that creates another possibility. The robot may become cheaper, but the factory may become smarter. More machines can collect more operating data, more factories can experiment with automation, manufacturers can learn which tasks are easiest to automate, suppliers can respond. Software companies can build around those machines, and the entire ecosystem can begin improving together. That's the part that could become difficult for competitors to ignore, because competing against one cheap product is relatively easy. Competing against an entire network that keeps learning, scaling, and reducing costs is much harder. For American manufacturers, the question isn't simply whether a Chinese robot can enter the United States. Trade rules, security concerns, industrial policy, and supply chain strategy can all influence what equipment actually reaches American factories. The deeper question is different. Can American manufacturers achieve similar productivity gains while maintaining competitive costs? That's not an anti-American question. It's a manufacturing question. And it's becoming more important because the global factory is changing. For years, companies could compete by moving production toward cheaper labor, but automation changes that equation. If machines become inexpensive enough, the cost of labor becomes only one part of the calculation. Then proximity to suppliers matters, energy matters, software matters, engineering talent matters, production speed matters. And the ability to change a factory quickly starts becoming a competitive advantage. This creates a strange possibility. Cheap robotics could actually make manufacturing less dependent on the old idea of simply finding the cheapest workers. Instead, companies may increasingly compete over who can build the most efficient production system. And that brings us back to the tiny number that started this story, $30. Maybe that exact price will prove too optimistic for a complete industrial automation system. Maybe the real cost will be much higher once controllers, software, safety equipment, integration, and installation are included. That's important because a cheap component is not the same thing as a cheap factory, but the underlying trend can still matter enormously. The cost of robotic hardware is becoming part of a much bigger competition, a competition over who can make automation accessible to more businesses. And if that cost keeps falling, the consequences could be surprisingly human. A small factory owner may not be forced to choose between hiring more people and rejecting a new order. A manufacturer may be able to bring production back from somewhere else because automation changes the cost equation. A company that once couldn't compete with a giant factory may suddenly have another tool. And workers may find that the most valuable skill isn't competing against the machine, but learning how to work alongside it. That's the hopeful side of this story, but there is another side. When automation becomes cheaper, competition becomes harsher too. A factory that can produce more with fewer resources can force other factories to respond. Prices can fall, margins can shrink. Some businesses will adapt quickly. Others won't, and the companies that survive may not be the ones with the biggest factories. They may be the ones that can change fastest. That's why a cheap robot arm deserves attention. Not because one machine is going to destroy a $100 billion industry overnight. It won't. The more interesting possibility is much quieter. The barrier to automation may be falling. And when the price of a technology falls enough, the question changes from who can afford it to who can afford not to use it. That is a much more powerful transformation. Because once automation becomes ordinary, the robot itself stops being the story. The real story becomes the factory around it, the suppliers, the workers, the software, the energy, the logistics, the customers, and the companies trying to survive in a world where production keeps getting cheaper and faster. So perhaps the most important thing about a $30 robot isn't the $30, it's what that number represents. A world where industrial capability is no longer reserved for the biggest companies. Where smaller factories can experiment with automation. Where manufacturing ecosystems compete not just over products but over the cost of making those products. And where China, the United States, and the rest of the world are being pushed toward a new industrial race. The first revolution made factories possible. The second made them massive. The next one may make advanced automation ordinary, and if that happens, the biggest disruption won't come from a robot suddenly becoming incredibly powerful. It will come from something much simpler. Millions of businesses realizing that they can finally afford to use one.